This is shop talk. Your straight diameters hit print, your face is dead flat. Then the taper or the radius comes out oversized by a few thou. And the code looks fine. The problem isn't the code, it's tool nose radius comp, and a single number on your offset page you probably never touched. Here's the thing, the control doesn't know on its own. Your turning insert isn't a sharp point. It has a radius on the tip, usually 0.4 or 0.8 millimeters. When you program a coordinate, you're programming where an imaginary perfectly sharp point would be. That imaginary point sits tangent to the insert radius. On a straight OD cut or a flat face, it doesn't matter. The radius touches the part at the same Z or the same X either way. But the second your toolpath angles or curves, the real contact point shifts off that imaginary point. On a 30-degree taper with a 0.8 millimeter nose radius, that geometry error can easily put you a few thousandths oversize. On a sphere or a contour, it gets worse. The math doesn't care how good your program is. That's what tool nose radius comp fixes. The control offsets the path by the radius in the right direction, so the actual contact point follows the print. You turn comp on with G41 or G42. G41 is left of the cut direction, G42 is right. On most lathes, with the turret behind the spindle and standard OD turning, G42 is what you want. G40 cancels it. Always. Every comp on must end with a comp off, or your next tool change will start its rapid with the offset still active and slam into something. Now here's the part nobody explains. Just turning on G42 isn't enough. The control needs to know which way the insert is facing, which corner of the radius is doing the cutting. That's the tool tip orientation number. On the offset page, every tool has a number from 1 to 9. Each number is a position on a tic-tac-toe grid showing where the imaginary tooltip sits relative to the insert center. A standard OD right-hand turning tool, turret behind the spindle, is usually a 3. A boring bar going the other way is usually a 2. If you leave that number at 0, which is the factory default on a lot of controls, the comp math has no direction. It might apply the offset to the wrong side of the radius entirely. Your taper still cuts oversize, sometimes worse than with no comp at all. Most lathe operators were never taught this chart. They set the tool length, set the X and Z, leave orientation at 0, and then blame the program or the insert when tapers come out wrong. It's not the program, it's that one field. 2 more things you have to get right. First, the radius value itself. Your offset page has a column called R, or nose radius. Put the actual insert radius in there, 0.4, 0.8, whatever's on the box. If that's 0, comp does nothing. Second, lead in and lead out. Comp doesn't activate on the line where you write G42. It activates over the next motion move, so you need a clean linear approach move, not a cut, between G42 and the start of your contour. Same on the way out, before G40. Skip the lead-in, and the control tries to ramp the offset on while you're already cutting. You get a gouge right at the start of your taper, or a witness mark you can feel with a fingernail. Every time. So the checklist is 4 things. R value set, orientation number set, G41 or G42 active, clean lead-in and lead-out. Miss anyone and comp either does nothing or does the wrong thing. One more thing worth knowing. Some CAM software outputs the toolpath already compensated for the nose radius. If your post does that, you do not turn G42 on. You double compensate. On an OD that leaves the part oversize, in a bore it cuts undersize. Either way, it's wrong. Check your post before you assume. Quick way to tell. If your CAM output has G41 or G42 in it, it's expecting the control to compensate. If it doesn't, the path is already offset and you leave comp off. If you've made it this far, here's the takeaway. Straight diameters don't need comp. The moment your path angles or curves, the insert radius creates an error your program can't see. Set the R, set the orientation number, called G42, give it a lead-in, cancel with G40. That's the whole job.